All right, we're going to screencast the practice problems for the final. And the first problem is a velocity problem. So the equation that we're going to need for this is velocity equals displacement divided by time. And in this case, the displacement is 4.8 meters and the time is 1.2 seconds. So when you solve this, you're going to be left in meters per second. And so you'll have your answer in meters per second. And number two is also dealing with, this one's dealing with speed and distance and time. So if you think about your triangle, we have speed, distance, and time. And in this one, you're solving for distance. So cover up distance equals speed times time. And in this case, we have 20 meters per second times 5,986 seconds. And so our seconds cancel. And once we do the multiplication, we'll be left in meters. Number three is an acceleration problem. So we're going to deal with our final velocity minus our initial velocity divided by time. And so our final velocity is going to be 180 meters per second. And our initial was not moving, so that's 0 meters per second. And the total amount of time was over 10 seconds. So we're going to end up with 180 meters per second divided by 10 seconds. So when you do the math on this, you're going to be left with meters per second, which is going to be a meter per second squared. All right, we have another acceleration problem. In this case, we're going to be slowing down, so we're going to get a negative velocity. So in this case, acceleration equals v final minus v initial divided by time. And we're coming to a stop, so it's going to be 0 meters per second minus 7 meters per second divided by 3 seconds. So when we do this, we get 0 minus 7 is negative 7 meters per second divided by 3 seconds. So your answer is going to be negative, because a negative divided by a positive is a negative, and you're going to be left with meters per second squared. Our next one is a speed problem again. So if we look at our triangle, speed, distance, time, and we're going to be solving for time, so we cover that up. So time equals distance divided by speed, and our distance is going to be 200 meters, and we divide that by our speed, which is 1.77 meters per second. Meters are going to cancel, and you're going to be left in seconds, which is the time. A momentum problem. So our equation is P equals m times v. Remember, P stands for momentum, and mass and velocity. So we're dealing with 96 kilograms times 11 meters per second. So when we do the math on this, you're going to end up with the units of kilogram times meters per second, because you see none of these units cancel. So we have another momentum problem. This time I'm going to use the triangle for momentum. And we have mass times velocity and momentum on top. and we're trying to solve for mass. So it's going to be mass equals the momentum divided by the velocity. Our momentum is 555 kilograms times meters per second. We're dividing that by a velocity of 12 meters per second. And so our meters per second cancel, and we're left in kilograms. Now we have a density problem. And remember, density equals mass divided by volume. And we have a mass of 1,321 grams and a volume of 743 centimeters cubed, which, remember, a centimeter cubed is the same thing as a milliliter. And when we do the math on that, we're going to be left with grams per cubic centimeter, and that is the unit for density. All right, we have another density problem. However, on this next one, we're going to have to figure out the volume using the rectangular prism equation. So length times width times height. And we're dealing with 3 centimeters by 5 centimeters by 4 centimeters. And so a centimeter times a centimeter times a centimeter is going to give us 60 centimeters cubed. So now we have our volume to put into our equation. And our initial mass is 80 grams divided by 60 centimeters cubed. So when we get our answer, we'll be in grams per cubic centimeter, and that is the units for density, so we must have done that right. Now, on the next problem, we have to figure out what is the mass in a density problem. So we take a look at our triangle, DMV, and we're solving covering up mass. So mass is equal to density times volume. And in this case, we have a density of 0.917 grams per milliliter, and we're going to multiply that by the volume. However, we have a cylinder, so we've got to calculate the volume of the cylinder first. So we're going to go with our equation for the volume of a cylinder, pi r squared h, and pi is 3.14, times our radius, which is half the diameter, 1.4 centimeters. And we're going to square that, and then we're going to multiply that by 5.83 centimeters. So remember, do this first on your calculator. So take 1.4 times 1.4, then times pi, then times the other centimeter. So we're going to end up with centimeters squared times a centimeter, which is going to give us a centimeter cubed. And in this case, we're going to end up with something like 35.88 centimeters cubed. So now we're ready to, that's our volume, so now we're ready to plug that back into our initial equation. And you can see that milliliters and centimeters, they're the same thing, so they cancel. We're left in grams, and so now we've found the mass in grams. All right, we'll try one more before the kids get in here. So we're dealing with another density problem. This time we're solving for volume, so mass over volume. So we're going to cover up volume. Volume equals mass divided by density, and our mass is 450 grams, and our density is 0.665 grams per milliliter. Grams cancel. We're left in milliliters, and so that'll be our final answer.